Assalamualaikum and hi everyone. My name is Ilya Mizati binti Muhammad Ismail, matrix number 17161078. Today, I will show you how to make salt cubic crystals. Firstly, let's understand the structure of sodium chloride. Sodium chloride is an FCC, or known as a face-centered cubic crystal structure. In the crystal lattice of sodium chloride, each sodium ion, Na+, is surrounded by 6 chloride ions, Cl-, and vice versa, resulting in a tightly packed structure. The sodium ions occupy the corners of the cube, while the chloride ions are positioned at the center of each face of the cube. Sodium chloride is an ionic compound. Strong electrostatic forces hold together the positive and negative ions due to their opposite charges. So, how do the crystals form? It involves 6 different steps. First, dissolution. Salt was added to a solvent, that is water, which dissolves it into constituent ions, sodium and chloride. This is because water molecules surround and separate the sodium cations and chloride anions. Second, saturation. When salt was broken down its ion in the solution, more sodium chloride can be dissolved. Salt was added in until the solution becomes saturated so that no more salt can be dissolved. Third, nucleation. Nucleation occurs in a supersaturated solution. It involves the formation of tiny clusters of ion, acting as the initial building blocks of crystals. Fourth, crystal growth. Once the crystal nuclei form, they serve as templates for further growth. Additional sodium and chloride ions from the surrounding solution attach to the existing crystal nuclei, gradually building up the crystal lattice structure. Fifth, crystalline structure. The sodium and chloride ions arrange themselves in a regular repeating pattern, forming a 3-dimensional lattice structure. 6. Drying. The crystallization process can be facilitated by drying the solution through evaporation. By removing water, the solubility of sodium chloride decreases, promoting the precipitation and growth of solid sodium chloride crystals. Now, without further ado, let's get into the DIY. These are the items that we'll need: sodium chloride salt, containers, boiling water, stirrer, and coloring agent, which is optional. In my case, it didn't really work. It is preferable to use food coloring instead. For my DIY, I made 2 different batches using different temperatures of water. For the first batch, I added salt to a cup of freshly boiled water and stirred until it is saturated. Excess salt was removed and the solution was put into 3 different containers with different surface areas. The largest container was placed in the room while the smaller ones were placed outside. For the second batch, I added salt to a cup of still boiling water and stirred until saturated. Removed the excess salt and placed it into containers. One container was kept in the room and the others was left outside in the sun. After several days, results can be seen. The first batch was a success, while the second was not. Freshly boiled water has a higher temperature than boiling water, hence it was able to dissolve more salt in the solution. Let's take a look at the good results, shall we? I've been wanting to use that template for a while now, pardon me. Let's have a closer look at the crystals. Here, I have divided them according to their containers. The container with the largest surface area at room temperature produced the largest crystal in comparison to others. while for the other two containers that were left in the sun produced smaller crystals. This is medium in comparison, while this one is the smallest. This is from the container with the smallest surface area, and this one's a slightly bigger one. The factor for the different sizes of crystals produced is not only due to the surface area of containers, but also due to the difference in the evaporation rate from each container. The container with the largest surface area has the slowest rate of evaporation because it was placed at room temperature. For the ones in the harsh sun, the smallest container produced medium-sized crystals and had a slower evaporation rate than the slightly larger surface area that produced small-sized crystals. For further clarification, I have included a table of comparison. Some further improvements that can be made from this DIY are using both small and large surface areas in both places, as in the indoors and outdoors.